You see this transporter. There is a transporter found on the body of beta cells called GLUT2 transporters, glucose transporter type 2. It is very important for you to know that on the beta cell you have these GLUT transporters, which is type 2. The reason is because GLUT2 transporters are independent of insulin. So it means they do not need insulin to be active. So what happens, since in the bloodstream now you have high blood glucose, glucose now comes into the cell. It allows the entrance of glucose into the cell. So when glucose is in the cell, it undergoes phosphorylation, it becomes pyruvate, it becomes acetyl-CoA, which is now taken to the mitochondria through different processes of the Krebs cycle or the citric acid cycle, where you have your NADH and FADH2 being produced. These are now further taken to the electron transport chain to produce ATP by a process called oxidative phosphorylation. Please go, and I'm going to make a video on glycolysis and Krebs cycle, but you need to know these things, that when glucose is being broken down to pyruvate and down to acetyl-CoA, acetyl-CoA is taken to the mitochondria, which is now being processed, some little modification in the mitochondria, to give you NADH and FADH2, which are now taken to the electron transport chain through oxidative phosphorylation that produces ATP. So the end game here is to have ATP, adenosine triphosphate, an energy source for all living organisms. So that's what happens when glucose go into this. So but before I bring you down here, since we now know this little illustration that I need ATP whenever glucose comes into the cell, now let's come to this side. This is my DNA. My beta cell is being triggered to produce insulin. On the DNA in the cell, there is a gene that codes for the production of insulin. So let's say this is where the gene is. So you do know that when genes are being transcribed, they undergo transcription, they become mRNA, messenger RNA, because whenever you want to produce anything, you need to have copies of those things. There are processes in which you need to produce them. So there are copies. These copies are being saved in the gene. So how do we transcribe and translate these messages that the body wants for the production of insulin? So the gene undergoes transcription. When they undergo transcription, they become mRNA. This mRNA comes out and meets with the ribosome. Okay, it meets with the ribosome because we need to translate this message. So when it meets with the ribosome, it becomes a protein. A protein subunit. This protein it meets with the ribosome. The ribosome it now translates this and becomes a protein. The protein now is being attached to a rough endoplasmic reticulum. When you have little modification in